Welcome to this week's superhero simulation. This week we're going to take a break from Mr. Freeze and look at the Green Lantern's power ring. So we're going to use Moldflow Design to figure out where our injection point should be and how eco-friendly the design actually is. As always, if you have any questions, feel free to reach out to me at james.herzing@autodesk.com or follow me on either of those Twitter handles. So, the Green Lantern, before we get into him, turns out there's a whole Lantern Corps, all sorts of colors out there. The only one anyone gives a shit about, though, is the Green Lantern. Also, green is my favorite color. So, is that a coincidence? I don't know. So the Green Lantern isn't just one guy, it's actually a whole bunch of them. And the first one is Alan Scott, the creepiest of all superheroes. Look at that guy. He's old, he couldn't beat anyone up, and he wears really tight pants. Next, flying in on the screen, Hal Jordan. He looks a lot more like a superhero. I like that one. Guy Gardner. He looks like a bully from high school in his varsity jacket. John Stewart, I got real excited thinking he was the guy on Comedy Central, but it turns out he's still just a guy flying saving a child. Kyle Rayner, again, looks pretty modern. I like that one. Simon Baz, apparently he got a gun. The ring wasn't doing it for him. Jennifer Lynn Hayden, better known as Jade. So not really the Green Lantern, but the Green Lantern's daughter. I believe Alan Scott's daughter. I figured, a girl, she's probably hot. I'll put her on here. She's green, but other than that, she's got it going on, so that's okay. And then Thal Sinestro, he's yellow, obviously, but he was a Green Lantern and went evil. Surprisingly, Sinestro is his name, and they still gave him a ring. I think they knew that was going to go poorly. And last but not least, Jediah Call? Apparently that's his name. He looks like a 5th grader drew him, but that's okay. We all have our own taste. So, what about the ring that we're going to be designing? Well, for all of those Green Lanterns, of course there are a ton of Green Lantern rings. So look at all these various designs that you could have on there. So perhaps one of those isn't actually a Green Lantern ring. I've had a very traumatic experience with ring pops myself. Ugh, just bad memory from my childhood. We won't get into that. Anyways, the one we're actually going to design or work on looks like this design. And we're going to use Moldflow Design to tell us a little bit more about this creation. So the manufacturability, the cost efficiency, and the plastic material impacts. Most important to me, of course. Carbon footprint, because I'm always like, I want to reduce my carbon footprint. I love the environment. And Moldflow Design does just that for me. So here we are in Inventor, and up in the top left corner we see our Moldflow Design toolbar, our manufacturability, our cost efficiency, and our plastic material impacts. So the great thing about this is it's always running there, so you're not actually even setting up an analysis. You can just go ahead and make design changes like we're about to do here and see how it affects your part. So on this work plane, I'm going to go ahead and create a sketch of a circle. So after I project this geometry to give me a place to start from, so let's go ahead from that center point and make a circle, and let's define it to be 0.85 inches. And from that we can choose to extrude the circle through both sides of the ring to give us a place for our finger to go. So let's switch that to cut and to two-sided. And there we go. We can click OK, and we have a nice place to put the ring on our finger. And now with that, you can see it automatically updates in the corner, 80%, 80%, and most importantly 95. So this ring is not going to kill anything in the ocean or something like that. So on these edges, we don't want to cut off our finger. That plastic can get pretty sharp. So let's go ahead and add a fillet. And if we drop that down, all sorts of information. But we're not learning Inventor here, so let's just go ahead and use that fillet radius, click OK. And again, you see the little bars go gray for a minute, and now 80, 80, and 95. So this is great. I thought adding that little bit of complex geometry in there might make it a little worse, but so far so good. Now let's go ahead and hide this work plane and turn on this sketch that I conveniently have created here already. And let's extrude the green lantern shape there. And if we get into a better view, we know we don't want it to go up, we want to cut some material away. So we can just drag this down, or alternately, we can type in a number, which is what we're going to end up doing. So let's go with 0.1, and if we rotate that around, we can see that it looks like it's going to make a good cut for us. Click OK. And now our bar does change. Cost efficiency is at 86%, but manufacturability is down to 60. So what's the problem? Well, you see everything that we can take a look at and that has an exclamation point by it. Wall thickness is really the big problem, as well as draft angle. So let's take a look at that wall thickness. And if we zoom in, we can see, look how thin that is, not to mention the connectivity between the little icon and the edge of the ring. So ideally we would do something to help with that. But since this is just a cheap toy, I'm not too concerned. But let's look at the weld lines, because even though it's cheap, we want it to look okay. So based on this injection point, which is what they picked for us automatically, it looks okay. And here's the little fill path. So that looks pretty cool. Let's go ahead and watch that again, because it's just pretty exciting. And of course where that material comes together, that's where the weld line is going to be. Makes sense to me. So let's go into the finished part view, and this is a more realistic rendering of what we'd be working with, so we can see some of the defects. Defects? Defects. How about that? Alright, so if we scroll around, we can see a couple of little sink marks, and of course that one little weld line. Not too bad. Okay, hold on. We're going to take a break right here and pause everything. So we're going to have a little bit of a contest here. So for the first 10 people who share this post, as well as comment on it with the end of this saying, or the end of this sentence, you're going to receive a $10 gift card. So let's see who can get to it first, or actually who's listened to the video this far. Here goes nothing. In brightest day, in blackest night, you fill in the rest of the sentence. One more time. In brightest day, in blackest night, fill in what the Green Lantern says after that. So again, comment on there, share it, and a gift card is going to be coming your way. Now what happens if we click the Add Location button and place another injection spot? Now we wouldn't actually do this, I don't think. And when we play, we can now see it filling. And again, that top edge really fills slowly. And now I would expect the weld lines to be on the side where the plastic came together. And when we come into the realistic view, we can scroll around and we can see just a slight mark over on the side, but ideally what we're going to be able to do is kind of hide that with our material selection. And of course what we're going to go with here is a bright green for our ring. And there we have it. Everything you could possibly want. That's the Green Lantern ring. We can now manufacture it and we're ready to go. We know what's in store for us. Hope you learned something here. Please let me know if you have any questions.